So let's do our last example for two proportion test. A skin doctor's office believes that more Generation X patients come in to have skin checks than millennial patients and would like to launch a marketing campaign based on the results. Conduct a hypothesis test at the 0.10 level of significance to determine if Gen X patients have more skin checks than millennial patients. Randomly selected participants were divided into two groups. In the Generation X group, 75 out of the 125 patients came in for skin checks, while 55 out of the 95 of the millennial patients came in for skin checks. Okay, so I've been given here my level of significance. I've been given group 1, which is Gen X, and 75 out of the 120 of them came in for skin checks. And 55 out of 95 of the millennial came in for skin checks. It did give me a directional pull. It says it believes that more Gen X patients come in than millennial patients. So that's that greater than. So I have done my hypothesis. Okay, I'm going to let P1 or sample 1 be Gen X. It's just easier because I believe that Gen X comes in more than the millennial group. So I'm given my number of events and trials for this problem. So for the Gen X or the sample 1, the number of events is 75. The number of trials is 125. For my millennial group, the number of events is 55. The number of trials is 95. And the level of significance is 0.10. All right, so let's do this together. So I'm going to go to Stats, Basic Statistics to Proportion. So again, I'm going to do summarized data, and I'm going to do 75 out of 125. And I'm going to do 55 out of 95. Okay, going to go to Options. I'm going to make this 90% since it's 10% level of significance. And I'm going to make this a greater than symbol because I believe that Gen X is greater than the millennials. Hit OK. Hit OK again. And let's see what I'm given. I'm given sample 1. I'm shown that I've got the N, the event, and I'm given a sample P of 0.60. Sample 2 is 95 for the N. The event is 55, and I'm given 0.57. Okay. So again, I believed if I go down here and look at my alternative hypothesis that the proportion of Gen X people getting skin checked is higher than millennial. But it's really not that much higher if you look here. So that's what we're looking at. We're trying to find if there's a difference. Z value is 0.31. P value is 0.377. All right, so let's go see the results. Again, Minitab gave me everything I needed. If you have questions about how to run it again, I have the directions in the PowerPoint. Okay. So what is the two proportion test statistic? It is Z equals 0.31. The p-value is 0.377. So my p-value, which is 0.377, is greater than 0.10. Because of that, I fail to reject the null, which means I keep the null. Okay, and why am I doing that? I've got a typo because my p-value was larger than my level of significance. Okay, so if I go back, let's quickly go back here. Okay, so I'm keeping this one, and I'm not keeping the other one. So at this 10% level of significance, there's not sufficient evidence that Generation X patients have more skin checks than millennial patients. And we saw that when we kind of looked at the samples that Gen X has slightly larger numbers, but not a huge amount. So why is this important? Because sometimes we make preconceived notions about different groups, and this is a way for us to check those notions. Because like this doctor's office believed that Gen X people come in more, I need to target more for them. Well, if millennials are coming in for the same thing, why would you be so specific about your marketing dollars? It might be better to do a bigger campaign for those two groups. So this is where this stuff really comes in handy when you're dealing with business stuff is you can be more precise in who you market to, on what groups you look at, but you also have to keep an open mind. Some things that you believe might not be true.